Hello, my name is Matt Marietta, and this is assignment 4 for CECS 327. And for this assignment, we are tasked with going over mm, configuring a network with routers and switches and virtual PCs. So we have we originally did two routers and then without the switches, and then one PC assigned to each. So it'd be a PC here to router 2, then to router 2 with PC. But now we have a switch for 3 nodes, and then that connects to router 1. And then we have the routers connected together, and then this has its own network separately as well. And this also has 3 nodes. And so first what we did to assign this was to, also we used the Cisco routers because originally we would just have the faster Ethernet ports, but in this case we needed the serial links to connect the 2 routers together. And so if we hover over this, you can see that the serial 10 is connected to R1, so router 1 on port serial 10. And we needed to configure that. So if we go on router 1, we can say, or we're in the config right now. So we exit, let's see, do I have, yeah, show IP route. So if we see its connections right now, we have the S, which is a static route that we had to initialize later. We'll get to that, and then C and then C. So we see that basically these routers are connected to their own networks, and then this router is connected to this uh, by the serial link. So this would be via serial 10. So this is showing that this is connected together, and the gate that you use is 192.168.100.0. So if we were to ping 192.168.100.2, it works because this is the IP for this one, and we're connected via here, so it works perfectly. And if we say show IP interface brief, yes. So we see that the fast internet is 0 here. So this is .1, and then this one would be .2, and this is also .1 for this to communicate with this. And we can also see that, or the table we had originally, it worked with our own network. So if we do ping, let's say 192.168.101. Since this is 1, we can't use 0 because that's the gateway. And then we can't use the last one since that's the broadcast. We can try pinging one of these to see if it just works. If we can do that. So that would be 3, which is going to be PC3 in this case. So 4 out of 5, and one time it timed out because sometimes it takes longer to go through. And if we actually go on PC1, let's try pinging it 192.168. Let's try pinging a different one which within the network. Let's try 101.4. So this should ping PC4. So yeah, we see that we get all our bytes back with really fast times because we're in the same network. But later, when we try to ping in a different network, it'll take longer because we have to go through these routes, and we didn't have this established initially. So the huge problem that we had at first with not being able to ping each other was because that we had these defined, and this router can connect to everything here because we're connected by links. But let's say if we wanted to get to this network from this PC, so ping from PC3 to PC5, we had to configure there to be an IP route for that PC. So what we did is if we go in the console and we say show IP route, so the static means that we statically made it, and C just means that we connected it via the links. So we have 192.168.102.024. So this is where we want to go through. So this is our destination. We want to get to this network, and then via this, so we're saying we go to this router because it's 100.2. So we want to go here via the serial 10. And so .30, it is subnetted because this is the subnet for the router 2's network. And we can say it would be, which one is it? It was IP route. We go in the config, but basically 192.168.102.0, and then we're going to do the subnet address, which we have to do 255.255.0 because we want to be in the same subnet, and then we have to put what is the next IP hop that we want to go to, because we have to say, okay, go to 192.168.100.2 because it knows where this network is, and so that's why it would work then. So it was a command right there. and that's how we get this S. And if we go to the same thing on router 2, show IP route, we see that it has everything as well. So it's connected by its own network here, and we have C and then the S, which is the static, and then we can connect to 101.0. So that's the network we're going to via this router. And yeah, so if we try to ping 192.168.100.1, which is just router 1, it'll work. And if we want to ping, let's try pinging from one PC to another, that'll work as well. Because now we have these where they both have trace routes where we can go through. So originally it would send it to this router, but it wouldn't go through because it didn't know which network, because it wasn't connected to it. So we set a static route. So let's try pinging 192.168. Or let's do show IP first to just see where we're at. So yeah, we're in 102.4 and /24. So we're in 255.255.255.0 subnet. So if we try to ping 192.168.101.4, so we're pinging PC4. So we get a timeout on the first one because we have to go through all these links. And so that's why it's taking so long for this. So if we were to ping, let's say 102.3, which is just PC5, then it would be a lot faster. See, we have 38 to 43 milliseconds on the first one because we have to go through all these networks. And now we have 1 millisecond and lower. So basically this, we had to just configure a specific route for this to work. And a router is very powerful in the sense that it can redirect this data based on what you initialize it as, and it helps us create a very large system of networks. Thank you.